During a frontal collision, occupants continue moving with the force of the vehicle's speed prior to the crash. Known as inertia, this force can carry occupants into the steering wheel, dashboard, or windscreen, causing serious injury. The purpose of seatbelts and airbags is to safely stop the effects of this inertia and protect occupants from possible injury. Seatbelts are designed to prevent occupants from sudden forward movements and provide excellent general protection from injury. They also ensure occupants are in the correct position for airbag deployment. Airbags are designed to deploy only during moderate to severe collisions and can operate in different combinations depending on the type and severity of collision. The system usually comprises front, side, and curtain airbags. Front airbags deploy in frontal or frontal offset impacts. Located in the steering wheel hub and passenger side dashboard, they are designed to minimize head, neck, and chest injuries. Side airbags protect occupants during side impacts and may also deploy during vehicle rollover. Located in the sides of front seats, they are designed to inflate between occupants and doors or B-pillars, minimizing head, neck, and chest injuries. Curtain airbags also protect occupants during side impacts and may also deploy during vehicle rollover. Located in the roof lining between the A and C pillars, they are designed to cover windows, minimizing head and neck injuries to passengers in both the front and rear seats. They are also designed to minimize the risk of an occupant's arms or body exiting the vehicle during a collision and to reduce the risk of injury from broken glass. So, how do all these components work? Sensors constantly measure deceleration and vehicle direction. The airbag control module samples this data continuously, monitoring for rapid deceleration. If sufficient deceleration is detected, the system takes action. Within about 20 milliseconds, it evaluates the speed and direction of the deceleration. First, the seatbelt pretensioner tightens the seatbelt across the occupant's lap and chest to restrain the occupant from excessive forward movement and ideally position them for airbag deployment. As the occupant's inertia drives them forward, a load limiter relaxes the seatbelt's tension in a controlled manner to reduce the amount of pressure on the occupant's chest. If the impact force is sufficient, airbags will also deploy at about the same time. In a frontal impact, a signal ignites a chemical reaction producing a rapid expansion of nitrogen gas, inflating the airbag within about 30 milliseconds.